Hello all. Now I am going to discuss about the quotients of exponential Fourier series. In the last session we have discussed about uh, exponential form of Fourier series, how to represent a function x of t over certain interval of time with the complex exponentials, and we have discussed about synthesis equation. Now uh, we are going to discuss about the evaluation of quotients of exponential Fourier series. In the trigonometric Fourier series also we have discussed or we have evaluated quotients a0, an, bn. Like that we are having the quotient in exponential Fourier series, that is nothing but c0 and cn. Okay, so first I am writing the exponential form of Fourier series, that is x of t is equal to summation n is equal to minus infinity to plus infinity Cn e power jn omega naught t, where omega naught is nothing but 2 pi by t. Now the same process what we have done in trigonometric Fourier series, to find out an we have multiplied with the function, to find out bn we have multiplied with the function. Like that we have to do the same process in trigonometric Fourier series also. Okay, so in the trigonometric Fourier series, to find out the an we have multiplied the x of t with cos m omega naught t function. Next, to find out the bn we have multiplied the x of t with sin m omega naught t. Like that we have to multiply with e power minus j k omega naught t to the x of t to get the Cn. Okay, multiplying e power minus jk omega naught t to the function x of t, means both sides over one period. We have x of t into e power minus jk omega naught t into dt over one period, right? That is t naught to t naught plus t naught to t naught plus t summation n is equal to minus infinity to infinity Cn e power jn omega naught t into e power minus jk omega naught t into dt is equal to, I am getting this summation outside of the integration, n is equal to minus infinity to infinity Cn. Now integration t naught to t naught plus t e power jn omega naught t into e power minus jk omega naught t dt. Now we have to do one conclusion, that is already we know that integration t naught to t naught plus t e power jn omega naught t into e power minus jk omega naught t dt is equal to, it will be 0 if k is not equal to n. If k is not equal to n, if I do the integration over certain interval of time or over one period, over one cycle, I'll get a 0. If k is equal to n, then I'll get a capital T. Okay, so I'm assuming that n is not equal to, n is equal to k. If I am assuming that k is not equal to n, then I'll get 0. If I'll get 0, I won't get any quotient to find. So we have to get the quotient Cn, we have to evaluate Cn, then only we have to assume that k should be equal to n, then only we'll get the right side value will get some value, that is capital T. If we get 0, we won't get any quotient to find. So here integration t0 to t0 plus t x of t into e power minus jk omega naught t into dt, and this total function is known as t into c k. Understood? This is totally written as capital T. Okay, and n is equal to minus infinity to infinity Cn. As n is equal to k, I can write Cn or Ck. Okay, so here Ck is equal to 1 by t integration t0 to t0 plus t x of t into e power minus jk omega naught t dt. Now I am changing the variable, changing the variable k to n. Then Cn is equal to 1 by t integration t0 to t0 plus t x of t e power minus jn omega naught t into dt. So here Cn is a Fourier quotient of the exponential Fourier series. Okay, and this equation is known as analysis equation. And earlier we have discussed about synthesis equation. This is analysis equation. Now what is the value of C naught? Means if I substitute n is equal to 0, what I'll get? C naught is equal to, that I am writing A naught T naught to T naught plus T into x of t into dt. Okay, so here the Fourier quotients of x of t, the Fourier quotients of x of t have only discrete spectra, because I am having Cn. Cn means for only n values we'll have the spectrum. We are not having, we won't have the continuous spectrum, because it is depending upon n is nothing but integer. So discrete spectrum we will have. Okay, the Fourier quotients of x of t only have the discrete spectrum, because the values of Cn exists only for discrete values of n, small n. And it is complex exponential Fourier series, right? So as it represents a complex spectrum, it has both magnitude and a phase spectrum. Okay, so here it has both magnitude and phase spectrum. Here the magnitude line spectrum, or the magnitude spectrum, is even function of n, and the phase spectrum is odd function of n. Okay, so about this we are going to see very clearly in the next session. So this is about the determination of Fourier quotients of exponential Fourier series, that is C naught and Cn. Thank you.